Hello everybody, it's your friend Daniel here and welcome to another video where today we're going to be explaining all the circuit symbols for GCSE and A-level physics. We're going to be starting off with the two most basic components, which are the wires and the switches. Now a wire in a circuit looks like this. It's a solid straight line, so it's important that when you're drawing your circuit diagrams you use a ruler, and the purpose of a wire is to carry current from one point to another. And while wires, in reality, do have a resistance, it is negligible, and we often treat wires in questions as having zero resistance unless otherwise stated. Now moving on to switches, there are two states a switch could be in, open or closed. An open switch has the flappy thing up and it does not allow current to pass through it, and a closed switch has the flappy thing down when drawn, which allows current to pass through it. Now then, the next component we'll be covering is the filament lamp or bulb. The filament lamp has this circuit symbol as shown below, and how it works is that as current passes through the filament in the lamp, it causes the filament to heat up, which causes light to be emitted through the bulb. However, as the bulb heats up, the resistance in the bulb increases, which can be shown by the decreasing gradient of this IV graph, as the gradient of an IV graph is equal to 1 over the resistance. Now, next up, we're going to be covering diodes, which are rather unique components, so let's jump straight in. Now, how a diode works is that it only allows current to pass through in a singular direction, as shown by this IV graph, where there is only a current if the voltage has a certain polarity. There are also light-emitting diodes which use the above circuit symbol and have the same functionality of only letting current go through in a single direction that they share with regular diodes. However, these also emit light when current passes through them, and they are generally more efficient than regular filament bulbs. Now, let's cover what provides power to all these unique components, the batteries and the cells. Now, a cell has a positive difference from the positive side to the negative side, which powers all components that are connected in between the two sides. The large line indicates the positive side, and the smaller line indicates the negative side. And then while it may be helpful, you're not required to draw the positive and negative signs while actually drawing this symbol. And a battery is a power source made by putting one or more cells in series and functions almost identically to an actual cell, to the point where most of the time when you're doing required practicals and experiments in your class, you're asked to model the battery you were given as a cell. Next up, we're going to be covering the circuit components used to measure quantities of electrical circuits. Now, first up is the ammeter, which measures the current going through any given component, and to do this, it needs to be in series with the component. Then there is the voltmeter, which measures the potential difference or voltage across any given component, and needs to be in parallel with the component to do so. And by having both the ammeter and voltmeter in a circuit, ammeter in series, voltmeter in parallel, you can then use the formula R equals V over I to calculate the resistance of any given circuit. Now moving on to resistors, which are used in circuits to manipulate the resistance at any given point in a circuit and to alter the potential difference. Now there are various types of resistors, so let's jump straight in with fixed resistor. This is an ohmic conductor, which means current is directly proportional to voltage, and its resistance is unchanged based on the conditions it's under, and its resistance always stays the same. Now, the variable resistor is very similar in that it's still an ohmic conductor. However, you can change the resistance of a variable resistor, and it's quite often like a dial thing, or you move like a spring and it changes the resistance of the resistor. Now then, the LDR and thermistor, unlike the variable resistor and the fixed resistor, are affected by the environment, with the LDR having a decreased resistance the higher the intensity of light, and a thermistor having a decreased resistance the higher the temperature. These have many usages, such as in streetlights and things like that. Honorable mention to the fuse, while technically not a resistor in the traditional sense, it works to prevent overflows in current by heating up when the current is too large, causing the wire to melt due to the fuse's resistance. There's also the heater, which as current passes through it heats up. Now it's very important that when you're drawing this, you draw the circuit symbol with 3 lines down the middle. I definitely did not lose any marks in my A levels due to drawing it with 4 lines. Anyone who's told you that is lying. Anyways, if you enjoyed this video, make sure to like and subscribe, as only a small proportion of my viewers are subscribed and it really helps with the channel. And I'll see you next time.